All right, 11.7 equations of circles. Let's blow this up a little bit so we can see a little better. All right, so today what we're trying to do, we're trying to actually write the equation of a circle if we're given a picture, or if they give us the equation, we should be able to graph a picture. And then there's some other questions that dive a little bit deeper and make you think a little bit more. But I'm going to say a couple things before we get into it too much. You know, this is the equation. If you Googled and said, hey, what's the equation of a circle? This is what the internet will show you. And it's completely accurate. I like to think of it like this, though. I like to think of it as, you know, it's x minus some box squared plus, that plus is always there, and then y minus some box squared equals the radius squared. All right, that's what R stands for, is the radius. So this H and K, these guys are basically just the center point. All right, what goes in those boxes, you know, that I kind of drew up here? They're going to tell you where the center of the circle is. So for instance, I look at this example over here to the right, and I find the center of the circle, and I'm like, all right, where is that thing? It is at 1, 2, 3 on the x-axis, and it's 1, 2 on the y-axis. So I can go up here to the above equation, and I can put in a 3 for the x, and I can put in a 2 for the y. I now see my center is at 3, 2. And then the radius of the circle, it's probably easiest to either go horizontal or vertical and go 1, 2, looks like it's 3 units. So my radius squared would be 3 squared or 9. So like the final answer for this particular equation is going to be x take away 3 squared plus, it's always plus, that never changes, y minus the 2 squared equals 9. And now I have the equation of that circle. And you can't put that in a graphing calculator because it's not a function. It fails the vertical line test. You'd have to enter it into 2, but Desmos, which is a great resource online, Desmos, you could definitely graph that circle using that equation. And you could actually play with the numbers too and see how the circle changes. So let's kind of use that fact, and let's go through some examples. I think it'll make it a little bit more clear. So let's kind of come down a little bit here. So example 1, write an equation for each circle with the given information. So they're just telling me where the center's at. So I'm going to kind of think about my generic template. You know, y equals box squared plus y minus box squared equals the radius squared. And I'm going to just insert the pieces. So the x coordinate is going to jump right there. The y coordinate is going to jump right here, and the radius squared would be 7 squared, which would be 49. Now when you write your final answer, you're not going to put the boxes in there, but that's how it's going to be. Now the big thing, this is huge, the big thing I want you to understand here is that the final equation, the coordinates are going to be opposite. The coordinates are opposite what you would think. You know, if I see the center is at a positive 3, positive 6, it's kind of weird that in the equation you have this minus 3 and this minus 6. So with circles and equations, it's always good to think opposites. This is going to kind of show itself here in example 2. And here in a second I'll quit doing the boxes and we can just kind of roll. But I'll do one more like this. So I do x minus box squared plus y minus something squared equals the radius squared. Let's just do the radius because it's right there and it's nice and easy. 3 squared, which is going to give me a 9 there. Now here's where it gets a little funny. This x coordinate, when I put negative 2 in the box, minus a negative really becomes plus. Now over here the 5 is positive, so I just stick it in the box and I get y minus 5 squared, and my 9 comes down, and this is the final answer. But notice if you were working backwards and you look at the equation, this plus 2 here is opposite of what it really is, and this minus 5 is opposite of what it really is. So in my mind, that's how I kind of roll, that's how I kind of do it. Now these two examples are kind of key because they're like, well, what if one of them is a 0, or what if it's centered at the origin? You know, they're both at 0. Well, these are even easier because when I write this one out, I could put in x minus 0 squared. There's nothing wrong with that. And then y minus a negative 4, or opposite, is going to be plus 4. And then my radius squared is 25. But this is kind of unnecessary. You don't really need to write x minus 0 squared. So you can just simply write x squared plus y plus 4 squared equals 25. So when you see this happen, you know that the center, when there's no parentheses there, you know that coordinate's 0. And then you know this one's the opposite. So looking at the equation, we could work backwards. So on this next one, there's actually going to be nothing with the x and nothing with the y. And you got to be very careful here, because I tried to trip you up a little bit, just like the SAT does. I put in diameter as 8. So remember, if you have a circle and the diameter is 8, well, the radius is half of that. The radius is 4. So when we square that, we end up with 16. So there's an example of one centered at the origin with a radius of 4. All right, the next couple were ACT examples. So I'm going to these are a little bit above and beyond what's in the homework, but for standardized testing, I thought I'd throw them in here. So let me kind of zip through these. So find the y-intercept. So remember, y-intercept is where I cross the y-axis. For a circle, the equation x squared plus y squared equals 81. Well, let's just sketch it really quick. Since I don't see anything here, I know the center is at 0, 0. So that gives me the center of the circle because there's no parentheses. Now, this is the radius squared. If the radius squared is 81, I got to do the square root of 81 to get the radius is 9. So I know I'm going to go out 9 in every single direction. Now, my y-intercepts are where I cross the y-axis. So there's a y-intercept chilling right here, which that point is at 0, negative 9. And then my other y-intercept is chilling up there, which is at 0, positive 9. So these two are the y-intercepts. Now, they didn't ask for it, but if they did, these fellas would be the x-intercepts. All right. Number 6, find the radius of a circle with the equation blah, blah, blah. So it's often common on the ACT, which is a lot more skill-based than the SAT. They just want to know, do you know how to find the radius? Well, this gives me the center, which is not needed in this problem, but let's just get a little practice because it's opposite. That would be the center. But to answer their question, the radius of the circle is, if this is r squared, I take the square root of both sides, so it would be the square root of 28, which is about, and I don't have a calculator here on me, so I'm just going to say 5 point something, something, something. Or you could get kind of fancy, and you could break that thing down using radicals and go square root of 4 times the square root of 7. Since 4 is perfect square, it's just 2 radical 7. That's probably what the ACT would like you to see. Whole point of that question is, do you know how to find the radius given the equation? I'm going to skip example 7 for right now because this is not on our homework. So I'm going to just skip to the next page. I'll do this one in class. And so now we got to be able to work the other way. They give you the equation, or I give you the equation, and you need to be able to graph it. So I look at this thing and I say, all right, the key points that I need to graph a circle, I only need 2 things. I got to have the center, and I got to have the radius. You give me those 2 things, I can draw it. So here we go. The center of the circle is at opposite, so that's a -2. Opposite, +3, so there's my center point, left 2, up 3 right there. My pen calibration's a tad bit off. And then the radius is the square root of 16, which is 4. So now I count out 1, 2, 3, 4, up 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. And these are the points that I kind of use to do my best. It's going to be kind of ugly, but that'll work. You get the gist of it. All right, let's try the next one. So center of this guy is at +4, -1, doing opposites again. So +4, -1, chilling right there. Square root of that is the radius, so the radius is 3. Go out 3, go up 3, go over 3, go down 3. Lock it in. Next, moving on down. Looks like we got a couple more here. So these got a few little weird things going on, a little weird twist. So this first one, the twist is there is nothing in the parentheses there, so that would be 0. The y, I got to do the opposite, so that's a positive 1. Be careful. The point 0, comma 1 chills right here. That's the center. The radius is the square root of that, so the radius is 6. So I'm going to come over 6, up 6, which is actually 7 because I started at 1, over 6 to negative 6, and then down 6, which would put me at negative 5. Missed my mark down there a little bit, but you get it. Now, number 11 is a little funky because I notice I got this plus 49 chilling over here. And if you're going to do this equation, you got to get the x term to the left, the y term to the left, and all constants or numbers by themselves have to be to the right. So I'm going to need to add 49 to both sides to make this look a little more normal, which would be x squared plus y squared equals 49. Now we're money. We got a center at 0, 0. We got a radius at 7, centered at the origin. Go 7 in every direction. Boom, boom, boom. And there you are. So I know I went pretty quick, but I think you should have enough skills to do one of two things. I give you a picture, you give me the equation. I give you the equation, you give me a picture. That's kind of the gist of this. And there'll be more nuances that come up in the homework, and we'll discuss those in class. All right, good luck and see you.